Hey everybody, and welcome to a video about power factor. Today we'll be going over what is power factor, just in basic terms. Hopefully it'll help you kind of read and understand the power factors that you have going on in your system, so that when you walk up to one of the meters or see something on a control board, you kind of have more of an understanding of what's going on. So the power factor is essentially the ratio of real power to apparent power, kVA. Okay, and that right there brings us to the three different types of power. So that in turn takes us to the power triangle. So here's the power triangle. You have the apparent power, kVA, which is a combination of the real power and the reactive power. Now, the power factor is associated with this angle right here, and the cosine of this angle, cosine of theta, is equal to adjacent over hypotenuse. The adjacent is kW. Hypotenuse is kVA. So there you have it. Now, unity power factor is when the power factor is equal to 1. And in that case, if you have unity power factor, your kW is equal to your kVA. If you go back to your trig class, you'll see that the apparent power, let's call this kVA squared, is equal to kW squared plus kVA r squared. So that's just going back to a little bit of trig. So the total sum squared of the apparent power is equal to the real power squared plus the apparent power squared. So now you can start to see kind of some of the relationships. Now, during unity power factor, the phase angle on the voltage is equal to the phase angle on the current, meaning that there's kind of the waveform of the voltage and current is kind of sitting on top of each other. When you have one starting to get pulled in front of the other, or one starts to lag the other one, then you start to develop this reactive power, and you start to get into these types of situations where your power factor is not unity power factor. So we'll kind of demonstrate that here with a couple of formulas. So your kW is going to be equal to your voltage times your current times the cosine of theta, and your kVAR, reactive power, is going to be equal to the voltage times the current times the sine of theta, and then your kVA is just going to be the voltage times the current. Okay, now you can see that when we have a power factor that is 1, sine of 1 is going to be 0, so this whole reactive power goes away, and cosine of 1 is 1, so now you have your kW equals VI, your kVA equals VI, and the statement that we mentioned earlier becomes true in that your kVA is equal to your kW. Okay. So now it's time to introduce you guys into a kind of saying in the industry, Eli the Iceman. So, Eli the Iceman. E is for your voltage. So if your voltage is leading or ahead of your current, then it's an inductive load. And if the current is leading your voltage, then it's a capacitive load. Now, in most industrial systems, you're going to see lagging load just because of the type of the nature of the equipment that's there. It's big motors and stuff that has a big coil that kind of acts like an inductance. So this is kind of what you're going to tell if your power factor is leading and lagging. The two aspects to power factor is the number and whether it's leading or lagging, and this is what they refer to if it's leading or lagging. So just by looking at whether it's leading or lagging, you can tell if you have an inductive system or capacitive system. Like I said before, most of the time you're going to see an inductive system. We have yet to see a capacitive system. So now, one more formula we're going to throw at you guys is if you if you're kind of walking up to a meter or something and you're not sure if the meter's calculating kW correctly, which many times is the case, just it could be a wiring issue or the settings are wrong or what have you. So you can calculate your real power by utilizing this formula. So you're going to have 3, if you have a 3-phase system, times VL, which is the line voltage, divided by √3, times your line current times the cosine of theta. Okay, now hopefully you can get all these parameters from your system. You're going to know the voltage just based on the system, and your current, you should be able to read that from the meter, and your cosine of theta, you should be able to get that from the meter as well. So you can run those calculations and see what's going on in your system, and if something funky is going on, please listen to part 2. If you do have a power factor that you don't think is right, for tips and suggestions on how to fix it. And if you have any comments or suggestions or questions, please leave them in the comments. Thanks.